But why the area under a graph? Well, let's have a look. So here we have a graph, a velocity time graph here, and that is modelled by the equation y equals a half x plus 2, where y is velocity and x is time, time in seconds. So, and that's what our graph here represents. So, like I said, it's the area under the graph. We're going to have a look at y. So, over here, we can see that our graph, the area under the graph can be represented by a rectangle and also a triangle. We could do a trapezium, but we won't worry about that now. This is just to get the point across. So what we've got here, we want to find out the area. So we're going to find out the area of the rectangle, and then we're going to find out the area of the triangle. We're going to add them together. So we'll say that our area of a rectangle, we know is length times width. Now we can write this down here. So our width is 6. Our length is 6, and it is 6 seconds, because that's how long it takes 6 seconds to go from there to there. And we're going to multiply that by 2, because that's how high it is. It goes 2 here, and it is 2 meters per second to get there. Then our next step, we say 12, 6 times 2 is 12, and we're going to say second meters per second. And I'm going to do that whole thing there. So I'll just multiply that. Now, we've got 12, and our 2 seconds cancel out, so we're left with 12 meters. That's why we find the area under the graph, because our other unit will cancel. We're going to do the same thing here with the triangle. So we'll say area of a triangle equals a half times base times height. So we'll say a half times the base, which is once again 6, and it's 6 seconds, times a height of 3, and it's meters per second. So our next line, a half times 6 is 3 seconds, times 3 meters per second. So we end up with 9 second meters per second. Our seconds cancel out, and we're left with 9 meters. So then our total area gives us 21 meters. So if something travels with this velocity, half x plus 2, for 6 seconds, they will travel a total distance of 21 meters. They will have accumulated 21 meters. In the next video, we're going to see how we do that with integration.